Hello, and today we are going to be discussing experimental research. Now, we've gone over statistical relationships, where we're looking at the difference between groups with Cohen's d. We've looked at correlation between two quantitative variables, where we're looking at correlation. But today we're finally going to be looking at experiments. So finally, with this lesson, we'll be able to imply causation. So, like I said, up to this point, we've been looking at correlation, which, since there's no manipulation of any variables by the researcher, we cannot determine causation. That was correlation. Now, with experiments, that is the point. We want to determine causation. We want to say that one thing is causing a change in another. So, the point with experimentation is if we can keep everything between those two things the same, those two groups the same. Again, we're looking at the differences between groups here. If we keep everything between those two groups the same, except that variable we're manipulating, and there's a difference in whatever we're looking at between those two groups, we can say, hey, that thing that we changed, everything else is the same except this one thing we changed. And that is what's causing this to happen. So we want to make experiments, the two conditions, as close as we can, because then we have more certainty that this is, in fact, this is causing the change. So the thing that we're manipulating in an experiment is known as the independent variable. That is what is changing between the two conditions. So if we had an experiment where we're looking at, oh, I want to test students based on, half of the students had a study guide for research methods and the other half did not. And we're going to test and see, we're going to compare the exam scores between them. Our independent variable is the presence or being given a study guide, where one condition is they were given a study guide and the other condition is there was no study guide given. And then we'd be looking at the dependent variable, that it would be the test scores. That's what we're comparing between the two groups. Another example, we've talked about aggressive driving. Let's say we have a simulation and we're examining the dependent variable that we're comparing between groups is aggressive driving. How often people display aggressive driving behaviors. They're flipping people off, they're yelling, cutting people off, speeding, what have you. To set that up as an experiment, we can have a simulation. It's a little safer than actually driving, just to be safe. So we have a simulation and maybe we have our participants, let's say we have 100, 50 of them are placed in the simulation of maybe, Oklahoma traffic at 2 o'clock in the morning. I don't imagine many people out, or just maybe at the same time. So Oklahoma traffic at 5 in the afternoon, where they're kept constant, where they are kept in a rural area, so there's not much traffic. Then we compare it with LA traffic at 5 p.m. There's going to be a big difference. So we compare this little to no traffic condition to the heavy traffic condition. And we compare these two conditions to see how they fare in terms of aggressive driving. And let's say that the LA traffic condition displays those drivers placed in that simulation have more aggressive driving. We can say, hey, it's because of the heavy traffic, that manipulation that we did as the researcher, versus the 5 o'clock rural traffic, which I don't imagine to be much. We say, oh, that heavier traffic, more cars on the road, caused drivers in our simulation to exhibit more aggressive driving behaviors. So again, you want to make sure that you measure the dependent variable the same for each condition, be it heavy to little traffic, or if we're going to give a study guide to some of our participants and no study guide to the other participants, we want to make sure they're taking the same exam in that example. If we give the study guide people a super easy test and then the no study guide people a super difficult test, it's like, well, how do we know that it's not the test, the difficulty of the test that's causing a difference between these two groups, as opposed to just whether or not they are whether or not they were provided a study guide or not. So with internal and external validity, we have the independent and dependent variables down. Again, Independent variable is what we manipulate in the experiment. Oh, I'm going to put you in a heavy driving or a heavy traffic driving simulator, and you're going to have a little to no traffic driving simulator, or I'm going to give you a study guide, or I'm not going to give you a study guide. Those are conditions of the independent variable. We've manipulated that aspect of the experiment. The dependent variable is what we're comparing between those two groups. So again, between the heavy and little traffic conditions for our driving experiment, what we're comparing across those two groups, our dependent variable is the aggressive driving tactics, or behaviors. Let's see if people in the little traffic condition display less aggressive driving behaviors than those in the heavy traffic condition. Or again, with the example of the study guide or no study guide, those are the conditions of the independent variable. And we have the dependent variable of test scores. We compare who scored better overall, the people with or without the study guide. So we have something known as internal and external validity when it comes to experiments. We'll be discussing validity later on in the semester. However, that is a different sort of validity. The validity we'll discuss later is going to be in reference to surveys or measures of a variable. But this internal and external validity, that refers to experiments. So when we keep everything constant in an experiment, and the only difference is the independent variable, I give you a study guide or I don't give you a study guide. The more the conditions are kept the same other than what you've manipulated, that's an experiment that has high internal validity. It's saying, okay, we've kept everything the same between them. We've given them the same exam. They tested in the same room, tested at approximately the same time. Everything is constant between these two groups. We've kept it as close to identical as possible, other than some of our participants had a study guide, the other half didn't. That would have high internal validity. Now, if we were to same test or same experiment where half of them get a study guide, half of them don't, we compare them using different exams. We test them at different times of the day. Maybe we test one early in the morning and the other condition late at night. If we were to be in a different room, maybe one of the testing conditions, one of the groups is testing in a classroom, the other is testing at a construction site because some reason that was the only place that was available. That would have lower and lower internal validity because those two conditions are not the same, or they're just straying further and further away from being identical to one another, other than, of course, participants being exposed to having or not having a study guide. External validity, so again, that's internal validity. Within the experiment, everything is kept at a constant except for the manipulation of the independent variable. External validity is how we are able to generalize it to the population. So the more, and I'll get into a little bit of how we can alter the external validity, but it's essentially how well can these conditions that we've demonstrated in our experiment be applied to the population? So a driving simulator, if we keep it as close to actual driving as possible, it might have decent external validity. But if we give our participants like, oh, here's a simulator for driving, and it's like an old 1980s arcade game style, or maybe 90s arcade game style, it's not very immersive. We give them a plastic steering wheel to simulate with. It's not even like close to the real thing, or what have you. If we just kind of make it so the testing conditions that the participants are in don't really quite match with the real life experience or the real life application of it, then it's going to stray further and further from external validity. So we have two things when it comes to experiments, and that is extraneous and confounding variables. Extraneous variables are similar to what we've talked about with correlation when it came to third variables. These are variables that can influence the responses of the dependent variable. So influence the test scores in our study guide or no study guide group condition, or influence or have an impact on aggressive driving tactics that are outside of whether you're in a heavy or little traffic driving simulator. A lot of times this can be as simple as, oh, the time of day. So if you're going to compare traffic at 5 o'clock in the evening, at 5 p.m. traffic, and compare that to 2 in the morning, like I almost did earlier, that could be an extraneous variable. Well, they weren't taken at the same time of day. So one is obviously has a lot more daylight than the other. 5 p.m. you're going to see a little better in comparison to 3 in the morning. Another example is age. I would wager a guess that probably elderly drivers, people that are above the age of 60 or 70, they probably may not demonstrate as many aggressive driving behaviors, but perhaps younger drivers might. Just depending. Mental health and individual traits. Let's stick with individuals' traits. And we're looking at that dependent variable of aggressive driving behaviors. And again, keep in mind that our two conditions, our independent variable was being in a heavy traffic simulation where you're in LA traffic at 5 p.m. or in a little to no traffic simulation where you're in a rural area, be that Oklahoma or Arkansas or even parts of California, but you're in a rural area at 5 p.m. Very different levels of traffic you're going to be experiencing there. Individual traits, in terms of what individuals bring to the table, keep in mind we're looking at aggressive driving tactics or behaviors. So maybe it has nothing to do with the traffic conditions of the driver, but there might be some people that are just naturally more aggressive or just kind of less patient. And so even if they have little traffic, if someone is going slow in front of them, even if there's no one else on the road, or what have you, they might be just more privy to display aggressive driving tactics. So there's always a lot of extraneous variables that are contributed to experiments. And so even though we can determine causation with experiments, there's always a shred of doubt that we have, because we can think, oh, well, we did find a big difference between our study guide and no study guide group when it came to the exam scores, but it could be that maybe the time of day, if we weren't able to get it at the same time or at the certain time of day that we tested them, maybe it's just some people are more awake at 8 o'clock in the morning and they're more willing to take a test at that time as opposed to 1 or 2 p.m. after they've eaten lunch or what have you. One way to limit extraneous variables is to control for them completely. So to take out gender and age and time of day, and maybe even looking at the difference between psych majors and biology majors or any other major for that matter. Maybe if we're testing, the study guide and no study guide condition, instead of having an array of students of various ages and genders and majors, I think I said that. No, I said ages. Anyway, we can say, okay, we only want 20-year-old women who are psychology majors. And okay, driving in 5 p.m. traffic or taking this exam at 5 p.m. or what have you. We only want 20-year-old women who are psychology majors to take part in our study. That's controlling for, okay, there's not going to be a gender difference because we're only looking at women. There's not going to be an age difference. That can't be an extraneous variable because we've only tested 20-year-olds. We can't have the extraneous variable of maybe different majors will test differently on this exam, have a different knowledge set, or different majors, what have you, because we've only looked at psychology majors. So cool, we don't have to worry about those extraneous variables, except when we control for extraneous variables, suddenly that kind of dwindles the extraneous validity. That point I made earlier in the previous slide, where how well can we generalize this to the population? How well does this match the conditions of real life? Well, not everyone that drives or not everyone that takes tests is a 20-year-old female psychology student. There are tons. There's 21-year-old female psychology students. There's a lot of male psychology students. There's a lot of transgender psychology students, intersex psychology students. There's also biology students. There's a bunch of people out there that definitely don't fit the bill of a 20-year-old female psychology major. So when we control for extraneous variables, yes, that eliminates that, like, ooh, this couldn't possibly be something that contributes to changes in the dependent variable because we only have 20-year-olds or we only have women. However, since the world is not made up of 20-year-old psychology students who are female, it doesn't really have that high of external validity because it can't be applied to the entire population. Similar to how Freud's Freud's studies, they don't have very high external validity because he was mostly looking into his patients were middle-aged, upper-class white women. Not very good external validity because that is not many people. That's a small population of the world, but not everyone is that. So take Freud's thing, keep his findings with a grain of salt, because it doesn't have very high external validity. So I talked about how there's extraneous variables. Now I'm going to talk about confounding variables. So these are variables that differ across conditions of the independent variable. So whereas with extraneous, that's just everything as a whole. Everyone that is, what could contribute to changes in aggressive driving or in testing conditions? Well, it could be their age, their gender, their mental state, maybe they're pissed off just in that their emotional mood at the time. If you're pissed off, you're likely to drive more aggressively. Or if you're feeling kind of down on yourself or feeling kind of like you don't know anything, you probably won't perform as well on a test. You don't really have that academic confidence. Confounding variables, this is when we have already split the conditions of, oh, this group is going to have a study guide and this group isn't. Or this group is going to have the heavy traffic simulation at 5 p.m. This group isn't. Or this group's going to have the little to no traffic simulation at 5 p.m. Well, confounding variables are referring to even when we've split our groups, even when we have the participants in each of our conditions and we're ready to test. It's the little things that are within those groups that causes change. So maybe we are selecting people for our driving conditions, right? The heavy to little, or the heavy and the little to no traffic conditions. Maybe just by sheer happenstance, just by accident, based on how we've split them into these groups, there's a lot more people who are aggressive, and maybe they've been to anger management classes. Maybe they have troubles controlling their temper, something like that. And we have a lot of those people that just so happen to be in our heavy traffic condition. So, and the other group has the little to no traffic condition. They have a more even balance of just, maybe they have some people who have short tempers. They have other people that are super patient. But just by sheer accident, we have a lot of people who just got out of anger management or are struggling with anger management that are in our high traffic condition. So they're going to be they're likely going to display more aggressive driving behaviors. But that wasn't necessarily because they were in the high traffic condition. It's because there was just a lot of participants in that group that were more prone to just have aggressive driving behaviors anyway. Same thing for if we were to have the study guide and no study guide condition. Maybe just by sheer accident, we happen to have people who are geniuses or people that have had multitudes of research experience. We just happen to accidentally place them in the group that has no study guide, let's say. That group is going to perform probably very well, but it has nothing to do with the lack of study guide. It's more because the people that are in that group, a lot of them just happen to have experience and knowledge in the subject that we're testing them on. So it's difficult to say, oh, it's because they didn't have a study. Oh, there was no difference between having a study guide and not having a study guide. Our groups perform the same. Well, maybe, but I'd say a study guide's helpful, in which case I would look at the participants and say, hey, a lot of people in our no study guide condition knew the material, so they wouldn't have needed a study guide anyway. The lack of study guide made no difference. So it wasn't a very good test in the sense that our groups, the group that was hypothesized to perform worse, they had a lot of people who knew the stuff. They didn't need that. So it's the confounding variables. Try not to get it confused with extraneous variables. I know it can get a little complicated, but you can think of confounding variables as an unintended and accidental additional independent variable. So not only do we have, we have the groups of little to no traffic or heavy traffic, but now we also have the groups by accident of people, a lot of people that were in anger management or just have temperament problems, and people who are more control, or the control group, the more even keel, overall a decent balance. Or we have the people that, you know, for our study guide conditions, we have the, yes, you have a study guide, no, you don't. But then we have that additional accidental independent variable or confounding variable of this group happened to have a lot of research experience and they knew the material on this 144 exam we're giving them, versus the other group that was just kind of an even batch. You know, some people might have had some experience, others didn't. It was, you know, it was more balanced. So keep that in mind. Those are some of the things that are part of experiments. We have independent and dependent variables always for an experiment. We have that internal and external validity, which again refers to internal is just how identical or how same the conditions of the independent variable are. And then we have the we have external validity, which is how well our experiment can be generalized to the population or real life. And then we have extraneous variables and confounding variables. Again, extraneous is before we even start splitting them off into groups, before we start splitting off our conditions of the independent variable in testing. Extraneous variables are just things that contribute to changes in the dependent variable. So that could be, you know, time of day you do this test, or age, or gender. Maybe men are more aggressive, have more aggressive driving tactics than women, or more aggressive driving behaviors than women, or vice versa. Maybe that has something to do with it. Extraneous variables have nothing to do with the conditions that we have set, but it's more so how are changes in the dependent variable affected? What are different things that could increase or decrease certain aspects of this dependent variable? Those are extraneous. Confounding is where we've split the groups and there's like there's an uneven balance. Maybe one group has a lot more aggressive drivers, or one group has a lot more passive people. Keep in mind that sometimes extraneous and confounding variables can be the same. Let's say age. Maybe in one group we happen to have a lot of elderly people, and the other group has just a more even balance of, you know, young and old, etc. But one group has a lot more elderly people, but it's a confounding variable because we have split our groups into, we have split our conditions into heavy and little traffic. And one of our groups just has a buttload of elder people in it. So that group is likely to display less driving or less aggressive driving tactics, but we can't really say for certain, it's because they were in the heavy condition, the heavy traffic, or the little to no traffic condition. It's like, well, yeah, but also there's like, out of the 50 participants, 40 of them were over the age of 70. So it could be the independent variable, but it could also be the confounding variable you didn't mean to have happen, which is there's a buttload of older people in this group. So that is our experimental research. If you have any questions, don't hesitate to email me or contact me in any way through Canvas or what have you. Also, don't forget my office hours. You can always stop by and talk to me there. But that's all I have for experimental research. We'll have an activity for it. But that's all, folks. So like and subscribe. Bye-bye.